Hi, my name is Mert. I am student of Electrical and Electronics Engineering Department. In this video, I will talk about my graduation thesis project. The subject of my project is providing occupational health and safety with IoT-based UHF RFID systems in production facilities. This project aims to prevent occupational accident that may occur with the integration of UHF RFID systems to production facilities. My project consists of two parts. These are hardware and software. UHF RFID reader antenna designs are in the hardware part of the project. The software section has a user interface. Uh, First of all, I will talk about antenna designs. And a total of 6 antenna designs were made, and one of them was selected for use in the project. All antenna simulations were done using CST Studio Suite program. And this is the first antenna design. This antenna name is O-shaped RFID reader antenna. You can see the shape of this antenna. And this table is parameter value of the O-shaped RFID reader antenna. And you can see in here S11 value of the antenna. Center frequency of this antenna is 926 megahertz, and bandwidth of this antenna is approximately 400 megahertz, and you can see the gain of this antenna is equal to 2.94 dpi, and the other antenna is S-shaped RFID reader antenna. You can see the shape of this antenna, and you can see also S11 value of this antenna. Center frequency of this antenna is 985 megahertz, and bandwidth of this antenna is approximately 600 megahertz, and gain of this antenna is 3.26 dBi, and the other antenna is G-shaped RFID reader antenna. You can see the shape of this antenna. This table for parameter value of G-shaped RFID reader antenna, and you can see the S11 value of this antenna, and center frequency of this antenna is 916 megahertz, and bandwidth of this antenna is approximately 400 megahertz, and gain of this antenna is 7.56 dBi. And let's look at the other antenna, F-shaped RFID reader antenna. In here you can see the shape of this antenna, and this table is parameter value of the F-shaped RFID reader antenna, and here S11 value of this antenna, and center frequency is 868 megahertz, and bandwidth of this antenna is about 200 megahertz. The other antenna is C-shaped RFID reader antenna. You can see the shape of this antenna. Here is the top layer of the antenna and bottom layer of the antenna. This is the parameter value, and S11 value is also you can see, and center frequency of the antenna is 816 megahertz, and bandwidth of these antenna is approximately 300 megahertz. And gain of these antenna is 5.86 dBi. This is the last antenna. His name is square-shaped RFID reader antenna. You can see the shape of this antenna. Here is the parameter value of the antenna, and S11 value of this antenna, and center frequency of this antenna is 920 megahertz, and bandwidth of this antenna is approximately 60 megahertz. And gain of this antenna is 4.84 dBi. And for use in my project, I preferred the square-shaped antenna, which is the last antenna of these 6 antennas. The working frequency of our RFID reader is 867 megahertz. So I have done parametric studies on the center frequency of the selected antenna. And first of all, I examined the effect of the M1 value on the S11 value. This length and this length is M1, and you can see this effect to the graph. M1 takes from 1 to 12. After I examined the effect of the K1 and K2 values on the S11 value. K1 is the here, and K2 is the here. And you can see the effect of this graph. K1 goes from 25 to 29, when K2 goes from 32 to 44 millimeters. You can see this effect of the graphs, and also you can see after this result, I added the parasitic element to the antenna. These and these are parasitic element, and after I examined the effect of the N1 value to the S11 value. N1 is the this length, also this length. You can see this effect to the graph. N1 value goes from 1 to 10, as you can see. And after this stage, I started optimization process. And after the optimization, change were made to the values which is marked bold in the table, as you can see in here. As a result of these changes, and center frequency of these antenna 867 megahertz, and gain of this antenna was changed to 3.5 dBi approximately. This was the work done in the first part of the project, and let's look at the second part of the project, which is user interface. I used Visual Studio while designing the user interface, and I used SQL Express for the program database. And let's run the program. First, we have see the login screen. If we don't register, we click on sign up and register to the system by entering username and password, and again password and email. And phone number. Click sign up button. Username has already been taken. Okay. Again sign up button. Registration successful. Click OK. And we create our registration in the system. If we forgot our password, click here. We enter our mail address to get the code. And click send. Code sent successfully. Check the mail. Enter the code here. Click verify. Let's enter the new password. And click save. Password reset successfully. Click OK. And let's log in into system now. Click login. Welcome to employee tracking system. And click OK. This is the main screen for the system. These are menu buttons. And click the employee registration button. The registration menu is open. And this button provides the RFID reader connection. After the connection is completed, when we press the read EPC number button, the EPC number which is defined to the employee comes here. There is no connection right now, so I will enter the number myself. First of all, let's enter the employee name and surname. Name is Mert, surname is B. Tracking number. Employee department, select, and birthday of the employee, I can select here, and blood group of the employee, and register date, you can select if you want, and gender, male, Finally, let's add the photo of the employee to the system. Okay, load. Here is the employee photo, and click the Add Now Employee button for the save. Registration successful. Click OK. And let's see the update employee registration. Click the button and update menu is open. There is a list in the update menu where we can choose the employee whose information we want to update, and we can select the employee whatever we want by click on it from the list. For example, I want to change the department and blood group of the employee Mert B. Let's change the department from, for example, fourth to first department, and blood group change the AB RH plus to 0 RH minus. And also I want to update the photo. I can select another PNG file and click load and click update button. Let's look at the change. Here is the Mert B, and you can see that his department has changed, and blood group is also changed. If you want, you can remove the employee from the list by click the button. Let's try. Mert B in here. I click the remove button, and let's see. And yes, his name does not appear to the list. This menu is, that's it. And let's see the employee tracking menu. Click the button and tracking menu is open. There is another list in this menu. The purpose of this menu is to keep track of which occupational health and safety equipment employee use. By clicking on the employee in the list, we can see the what equipment he or she is using. For example, we see the which equipment that Kenan currently uses. For example, which equipment that Osman currently uses, which equipments, and also Mert currently uses. As a result, we follow or track the employee in this menu. Let's see the last menu of the program. Click the button, information menu is open, and you can see the information about the environmental condition. These values here will come from the sensors that will be added to the system. The program is in its general form. Finally, let's sign out, and yes, and close the program. This was the work done in the user interface part of this project. Finally, let's look briefly at the titles of my thesis. And here is my table of contents, and these are forward table of contents, list of table, list of figure, abstract, özet. The first part of my thesis is introduction. This part has include automatic identification systems. These are RFID systems, comparison of different identification systems. The second part of my thesis is RFID system components. These are RF tags, RF reader, and RFID reader antenna. The third part of my thesis is fundamental parameters of antenna. These are S parameter, directivity, efficiency, gain, bandwidth, polarization, and Friis transmission equation. Fourth part of my thesis is sensor used in IoT based system. What is the IoT and what is the sensor to use, and you can see the different types of sensor, like humidity sensor, force sensor, gyroscope, carbon monoxide sensor. And fifth part of my thesis is CST simulation results. This part says include all antenna simulation results, as you know, and also comparison of simulated RFID reader antennas. Sixth part of my thesis is RFID positioning application and tech measuring robot. This part has include design of remote control RFID tech measurement robot and system components and principle of operation. RFID positioning application measurements, and the other part is software, which is user interface part, and the other part is conclusion, and last part is future work. And also appendix are in the my thesis, so the codes of the user interface are in the appendix A. And that's it. Thank you very much.